Objectives. Define titration. Describe the endpoint of titration. Explain how to conduct a titration. Describe how pH change during a titration. And finally, perform calculations to determine the concentration of an acid or base given titration data. What is titration? Titration is a laboratory technique in which the unknown concentration of a solution, known as the analyte, can be determined by another solution of known concentration called the titrant. For example, if we need to find the molarity of a solution of an HCl acid, a titration can be conducted where the acid is neutralized with a base whose concentration or molarity is known. In the titration, a measured volume of acid is placed in an Erlenmeyer flask with a few drops of indicator such as phenolphthalein. In the acidic solution, the phenolphthalein is colorless. A burette is then filled with a base such as sodium hydroxide of known molarity, which is then carefully added to the Erlenmeyer flask to neutralize the acid. At neutralization, the phenolphthalein will change from colorless to pink. The volume of the acid, the molarity and volume of the base used to neutralize the acid are then used to calculate the molarity of the acid. What is the endpoint of titration? The endpoint of titration occurs at neutralization. The color of the indicator changes at neutralization, indicating the endpoint. At this point, the pH meter can also record 7. The endpoint of neutralization, the amount of hydrogen ions and hydronium ions is equal to the amount of hydroxide ions. Here we can see the hydrogen ions are equal to the hydroxide ions. The moles of hydrogen ions are equal to hydroxide ions. What are the equipment needed to conduct a titration? A pipette, Erlenmeyer flask, a dropper containing indicator, a beaker, a clamp stand, a burette, a funnel, and a tile to visualize the color change. How can a titration be conducted? The first step is to place an amount of analyte, that is the unknown concentration, using a pipette in an Erlenmeyer flask. The next step is to add a few drops of indicator, which will change upon neutralization to the analyte in the Erlenmeyer flask. Third, we place the titrant of known concentration in a burette, and the initial volume is recorded. Finally, the titrant is added to the analyte in the Erlenmeyer flask until there's a color change, and the final volume is recorded. How does pH change during titration? Here, titration was conducted to determine the concentration of acid with a base of known concentration. 25 ml of the acid was placed in an Erlenmeyer flask along with a pH meter. The volume of the base and the pH values was recorded as the base was added to the Erlenmeyer flask using a burette. Initially, the pH was 1 since there was only acid present. However, as base was added, the pH gradually increased. The pH values showed a dramatic increase as the acid was neutralized by 25 ml of the base. The endpoint of neutralization occurred at the pH 7 when 25 ml of base NaOH was added. As more base was added, the pH continued to increase, producing a typical titration curve shown on the left of an acid being neutralized by a base. If the reverse was done and base was placed in an Erlenmeyer flask with a pH meter and the acid was added, the curve would begin at a high pH and end at a low pH, with the endpoint still occurring at pH of 7. How can we perform titration calculations? In a titration, 26 ml of 2.0 molar HCl was neutralized by 13 ml of NaOH. Calculate the concentration of sodium hydroxide. Here, we use the titration formula provided in reference table T. However, we will update it to account for the number of hydrogen ions present in the acid and hydroxide ions present in the base. Looking at our question, we identified the acid as HCl and the base as NaOH. Using this data, we list the given. Here, we notice it was one hydrogen ion present in HCl, so that's 1. The molarity of the acid is 2.0, and the volume of the acid is 26.0. While the base contains 1 OH, the molarity of the base was unknown, we listed as X, while the volume of the base was 13 ml. Substituting in our updated formula, we calculate that the unknown concentration to be 4.0 molar, where if we looked at the volume of acid 26 ml at 2.0 molar, we only needed 13 ml of the base. Therefore, the base must have been twice as powerful or twice as concentrated as our acid. The acid was 2, therefore the base was 4. Example 2. In a titration experiment, 28 ml of 2.0 molar H2SO4 was neutralized by 14 ml of NaOH. Here we ask to calculate the concentration of NaOH. Similarly, we identify our formula. The updated formula is listed. Next, we identify the acid as H2SO4 and the base as NaOH. Here we list our given. In this example, there are 2 hydrogen present in our acid H2SO4. So here, the number of hydrogen ion is 2. The molarity of the acid is 2.0 molar. The volume is 28 ml. While our base NaOH contains 1 OH ion. Here it's listed as 1. The molarity of the base was needed. We listed as X, and the volume of the base was 14 ml. Substituting in our formula, we calculate the molarity of the base to be 8.0 molar. Example 3. In this titration experiment, 16 ml of 3.0 molar HCl was neutralized by 8 ml of CaOH2. Here we ask to calculate the concentration of CaOH2. We list our formula with the updated one. Then we examine the question to determine which is the acid and which is the base. The acid was identified to be HCl, while the base was CaOH2. Here we list our given. In this example, HCl contained 1 hydrogen, therefore the number of hydrogen ion is listed as 1, the molarity as 3.0 m, the volume as 16.0 ml. The number of OH minus in our base, CaOH2, is 2, therefore it's listed as 2. The molarity is unknown, that is what we're calculating, it's listed as X, while the volume is 8.0 ml. Substituting in our formula, we determine the molarity of the base to be 3.0 m. Example 4. In this titration experiment, 25.0 ml of HCl was neutralized by 12.5 ml of 0.25 m NaOH. We need to calculate the concentration of HCl. Here we list our updated formula and we looked at the question for the acid. In this case, it is HCl, while the base is NaOH. In this example, we are asked to calculate the molarity of the acid. We looked at our acid, there's 1 hydrogen present, so that's listed as 1. The molarity of the acid is unknown, X, while the volume of the acid was 25 ml. Looking at our base, NaOH, there's 1 OH ion. The molarity of the base is 0.25 m, and the volume of the base is 12.5 ml. Substituting in our formula, we calculate the molarity of the acid to be 0.125 m. In our final example, example 5, titration data was given. In this experiment, a student used 1.4 molar HBr solution and the indicator phenolphthalein to determine the concentration of a KOH solution. The data for the first trial is recorded in the table below. Here we ask to set up to provide a numerical setup. So we use the updated formula and we look at our question to identify our acid. It is HBr. We identify the molarity and the volume from the data table, while the base volume is provided and we're asked to find the concentration. The given. For our acid HBr, there's 1 hydrogen, so the number of H is 1. The molarity of the acid is 1.4 m and the volume is 15.4 ml. For the base, there's 1 OH present. The molarity of the base is unknown. That is what we are supposed to calculate. Well, the volume after the experiment was 22.10 ml. plugging into our formula, we have the numerical setup as 21.56 equal to x multiplied by 22.10.